Hello, this is the beginning of Unit 3 in Algebra 1, and the honors topic in part for this chapter will be about compound inequalities. Now I want to talk a little bit about a quick review of inequalities before we get into the compound inequalities that you see here. The first statement, x is less than 3. What this means is that this indicates all values for x that are less than 3. Now we could attempt to list them all, but that would take quite a long time. 0 is less than 3. Negative 10 to negative 30 billion and beyond is all less than 3. So it's not really practical to try to list them. What we do instead is to graph it on a number line. So when you're creating your number line, first of all, make sure that your number line has some numbers in addition to just the number that you have. We're going to put in some numbers around the 3, so 0, 1, 2, 3, 4. Just don't make your number the boundary number being the one all the way on the end, or it also doesn't have to be absolutely in the middle. Now, we want x to be less than 3. 3 is that boundary point. We don't want to be anywhere bigger than 3, but the issue here is that we also don't want to be exactly at 3. If x is less than 3, we don't want to include 3 in the boundary. We still have to indicate that that is the boundary point, but we don't want to include that point in the actual graph. So what we do is put an open circle around that point. The open circle indicates that we are not including the 3, but the 3 is that edge, the end point of the graph. And I want all values for x that are less than 3, so 2, 1, 0, and anything less than 0, and then any decimals between any of those are all less than 3. And so my graph, which I'll do in yellow here, my graph will be to the left, and then an arrow showing that it's everything to the left. Now, when we have statements more like this, or like this, it's a little bit of a different situation. So, for example, 1 is less than or equal to x is less than 3. Now, you'll notice that we have the x is less than 3 as part of that. X is less than 3 is part of that statement. But we also have the statement 1 is less than or equal to x. So this inequality, this compound inequality altogether, is actually two inequalities in one. We have x is less than 3, and we have that 1 is less than or equal to x, or x is greater than or equal to 1. So when we graph this on the number line, we want to show both of these inequalities as being true at the same time. We'll create the number line and making sure we have both 3 and 1 in there. We'll just create the same one we did before. So that should be 2, 3, 4. Now x is less than 3 means we're going to have 3 as a boundary point, and we're not including it, so it's going to be an open circle. Now if x is greater than or equal to 1, then we have a boundary point at 1, but because we're including the 1, we want that to be a part of the graph. I'm going to fill that in, shade it in with a solid circle. Now graphing this is a little bit of the tricky part, because now we have, for example, that 4 is greater than 1, but it's not less than 3. And because we're supposed to be creating a graph where x is less than 3 and x is greater than or equal to 1, we're not going to include the 4. 4 is not part of the graph. 0 is less than 3, but is not greater than 1, so that's not part of the graph. 2 is both less than 3 and greater than or equal to 1. So 2 will be part of the graph. So will 1.5, 2.9, and all values in between those things. And so that's what, in fact, we do. We shade between those 2 points. And so this kind of like little cartoony barbell, dumbbell type thing, that is our graph for this type of compound inequality. The third type we have is that x is less than or equal to 1 or x is greater than 3. That means that either one of these statements could be true individually. Certainly we can't have a number that's both less than 1 and greater than 3 at the same time. That just doesn't work. It's not possible. So what we do is create our number line as usual. 0, 1, 2, 3, 4. And now I'm going to graph just these both separately on the same number line. X is less than or equal to 1, so I have a closed circle on the 1. And I want everything less than that. And then an open circle on the 3 to show that that is not included in the boundary point. And I want everything greater than that. So this would be my picture, my graph of x is less than or equal to 1 or x is greater than 3. Because I have all the values less than 1, that satisfies the first inequality, and then all the values greater than 3, that satisfies the second